Hello everyone, myself Sravanthi, working as an assistant professor in Department of Cybersecurity and Data Science in MLR Institute of Technology. Our subject is Automata and Compiler Design. In that subject, the first topic is the basic concepts of Finite Automata. To learn the Automata Compiler Design, we need to know what are the basic concepts, what are the terminologies we are going to use in a Finite Automata. So, in that, we are going to discuss what is alphabet, what is a string, what is a language, what are the operations that takes place in a string, and what are the operations that takes place in language. So these are the three concepts we are going to discuss here. So these are nothing but operations of a string which we have discussed till now. So the next one we are having is language. So what is a language? A set of strings of all of which are chosen from some sigma power star is called a language. Language is denoted by L. So all the set of strings we are going to call it as language which are chosen from clean star, nothing but clean closure. So that is represented with denoted by L. It is denoted by L. So we can also say a language is nothing but subset of sigma power star. We can also tell the language is subset of sigma star. So sigma star is nothing but superset of all the languages. If L is a language, then I can write L is a subset of sigma power star. See here, language which can be performed over sigma can be finite or infinite. We can have a language, either that language can be finite or infinite. See here, the second point, L equal to say empty braces. That is nothing but it represents me a empty set, but it is also a valid language. It is a valid language, but it is showing me empty, nothing is there. So nothing but empty language. So we are going to represent this as pi. We are going to represent it with pi. The next one is L equal to epsilon. Nothing but something is present in the brackets. Something is present. That something here I am having is epsilon. So nothing but it is representing me an empty string and it is also a valid language, but it is not a empty language. The previous one is pi is nothing but only I am going to have a empty brackets. Empty brackets shows means that it is a empty language, but I am having here something is present in the brackets. So that is why I am not going to tell it as a empty language. Something is present here. So that is why it is not a empty language. So that is the note here. See here. Pi is not equal to epsilon. Pi is not equal to epsilon. Pi is nothing but how we have written pi, empty brackets. And here I am having something is written here, that is nothing but epsilon. So pi has no strings, but here it is having something is present, that is 1. Epsilon is present. So that's why these both are not equal, pi and epsilon. That is pi is nothing but empty set and epsilon is nothing but empty string. Empty string is present. Some examples over language. Set of all strings of length 2 that can be generated over the alphabet A, B. So we are going to construct a language of length 2. What is the condition they gave? Set of strings of length 2 over an alphabet sigma equal to A, B. From these sigma equal to A, B, my condition is that should have the length 2 over an alphabet A, B. Now I need to construct a language over alphabet A, B, and my condition is length is 2. So what we can write? L is equal to, I need to take the length 2 from this alphabet A, B. So what are the things? AA, AB, BA, BB. I cannot write A, single B or 3 A's or 3 B's something. These all are not valid. Why? Because my condition is it should have length 2. It should have length 2. So A is 1 length string. B is 1 length string. 3A's is nothing but 3 length string. 3B's is nothing but 3 length string. So these are not valid. This is a valid. Why? Because each string is having of length 2. See here. AA 2 length string, 2 length string. BA 2 length string, 2 length string. So these all are nothing but 2 length strings are there. So that is the condition. Based on the condition, we are going to construct a language. See here, set the next one. Set of all strings which start with A that can be generated over the alphabet AB. So they gave X sigma equal to A comma B is the alphabet, and what is the condition they gave? That should start with A. It should start with A. In my language, I should have only that starting letter should be A. So how we have written? L2 is, here I am writing language L2 is equal to A, AA, AB, AAB, ABA, AAA, so on. These type of language is nothing but we are going to call it as infinite language. Why we are going to call it as infinite language? Because here they didn't mention any condition like what the length should be this much, that they didn't mention. Only they mentioned is the condition is it should start with A. Only the starting letter I should find A. If I have a starting letter, for example here BA instead of AB, so this is not valid. Why? Because it should start with A, but I am starting here it with B. So that is why I cannot write starting with B. It should have the starting letter is A, and after the starting letter I can find second letter, third letter, anything. It can be a combination of A and B. So that's why it is a infinite language. I can write so on, I can write something. There is no end point here. But coming to the L1 language, see here the first example, it is a finite because here they mentioned is length only 2. So only I need to write 2 length string. I cannot write more than 2 length strings, 3 length strings, 1 length strings. All these strings are not valid. So that is why this is a finite language. But the second example is it is a infinite language. But my condition only it should start with A. There is no condition that it should end at some point or I should have a strings of only 10 or 5. That is not mentioned here. So the next example is set of all strings which ends with 0 that can be generated over the alphabet sigma equal to 0, 1. See here, they gave the alphabet is 0, 1 and it should end with 0. So nothing but I can write the starting can be anything, but my ending is that should end with 0 only. I can have the starting letters either 0 or 1. It can be a combination of 0 and 1. But my ending should be the last point I should have is only 0. So that is the condition. So now these languages also we can tell it as infinite language. Why? Because there is no condition that it should have 3 length string, 2 length string. I can go so on, write 4, 5, 6, 10, so on. So that's why there is no end point. So that's why we are going to call it as infinite language. See here 0, it should end with 0. So from these alphabet 0, 1, 0, I am going to take only 1 length string. So the next one is 2 length strings I am taking 0, 0. I can also write 1, 0. The next one is 3 length strings. 3 length strings are nothing but 0, 0, 0. The last one I am having end point is 0, 1, 0. And I can also have 1, 0, 0, 1, 1, 0. And also 4 length strings I can write 1, 0, 1, 0. So the last one I am keeping it as fixed and I can change the starting letters. I can write anything, either 0 or 1 or combination of 0 and 1. So how we are writing these languages? These languages are written as sigma power 0 union sigma power 1. Sigma power 1 is nothing but 1 length string. Sigma power 2 is nothing but 2 length strings. Sigma power 3 length strings we are writing. So here we didn't write sigma power 0. Why? Because it should start with or end with 0. There is no epsilon in my question. There is no epsilon. Nothing but empty string is not accepted. It should have something. Some string should be there that is of 0 length. So that is the reason we are not considering sigma power 0 here. So it is nothing but we are going to write for a closures only. So these are few examples of language. So what are the operations that takes place under language? Union of a language. So union of 2 languages. So we do union for 2 languages. Let us take 2 languages as L is one language, M is the other language. So it is denoted by L union M. L union M. Union is nothing but we can also tell it as L or M or both. That is nothing but set of strings that are either in L or M or both. Either I can have the language in L or M or both I can consider. No duplicates are allowed. Duplicates are not allowed here. So if L equal to 001, 1011 is one language and M equal to epsilon comma 001 is other language. So L union M. L union M. So what we have, L union M is nothing but epsilon. So epsilon I am writing. So the next one is 001 and next 10111. But see here, in L language I have 001 and in M language also I have 001. But same string I cannot write twice. Duplicates are not allowed. So I can write, see here, the set of strings that are either in L or M or both. In anything I can write. Either I can take from L or M or both. But duplicates are not allowed. I cannot write same string again one more time. So that is nothing but union of languages. The next one we are having is concatenation of language. Concatenation of language is nothing but there are two languages L and M that is denoted by dot. L dot M I can denote or LM. Anything. Dot I can represent or LM. Frequently we use LM instead of writing dot every time. So or just LM is nothing but the set of strings that can be formed by taking any string in L and concatenating it with any string in M. So this is nothing but concatenation of two languages. I can take from one string from this end, I can concatenate in second string. So that is the thing. By taking any string in L and concatenating it with any string in M. See here, if L equal to 001, this is one language and M is equal to this is one more language. So what we are going to get? Epsilon is nothing but empty string. So directly the first part I am writing is I am concatenating all these four strings with the M1 string. So same thing, set of strings by taking any string in language L and concatenating it with any string in M. 001 into epsilon 001, 10 into epsilon 10, 111 into epsilon 111. So the next one I am concatenating the first string with the second string in M. So 001, 001, 001, 001, 10, 10, 001. Next, 111, 001. So nothing but I am concatenating one string from L language with one string in M language. So this is nothing but concatenation of language. It can be represented with dot, L dot M or ELM. The next one is closure of languages. Closure of language. Closure is nothing but star. So wherever we find a closure, so that is nothing but it represents it as a star. Okay. The closure of a language L is denoted by L star and represents the set of those strings that can be formed by taking any number of strings from L, possibly with repetitions. That is, the same string may be selected more than once. So I am concatenating all of them. See here what I am going to have. If L equal to 0, 1, then L star is nothing but all strings of 0 and 1. All strings of 0 and 1. Nothing but I can repeat the, see here, for this L equal to 0, 1, then L star is nothing but I can write combination of 0 and 1 and also I can write repetitions which we have discussed in the definition. Possibly with repetition. Same string can be selected more than once. More than once also I can select same string. Okay. So what I can write is, see here, 0, 01, 00, 01 or 001 or 0001 or 0101. Anything. I can select the same string twice also can be done. So that is nothing but closure of language. See here the second example. If L equal to 0, 111, then L star consists of strings of 0 and 1 such that 1 come in pairs. See here in my alphabet or in my language, I am having 1, 1, not a single one. So when I construct a language, I need to take double one, not a single one. Like 0101. This string is not accepted here. Why? Because here I am having double one. So I cannot divide that double one into single ones. So I can write 0110. This is accepted. But 0101 is not accepted. See here. 011 I can write. 4 times 1 0. How 4 times 1? 1 is nothing but 1 and 1 1. So 0 something we can write like this. But I cannot write 3 ones and 0 here. Why? Because it is 2 ones should come one after the other. But this is coming. But here only 1 1 I am finding. The other one is missing. So that's why this is not considered. So see here 010111. It is not considered. 101 is also not considered. Why? Because see here 0 after only single 1 is there. So but it should have 2 ones. Why? Because in my language I am having 0 comma double 1. Double 1 is nothing but 1 after the other one should be there. But here I am not finding that. So that is why this is not a valid. 101 is also not valid. I can write here double 1. This is valid. But 101 is not valid. So this is nothing but closure of languages. So till now we have discussed the central concepts, nothing but the basic terminologies we have discussed. What is a alphabet? What is a string? What is a language? What are the operations of a string? And what are the operations that takes place under a language? So these are the topics which we have discussed today. So in the next coming class, we will be discussing what is a finite automata and what is a deterministic finite automata, types of finite automata. Thank you.